In the depths of the past, Earth was vastly different from what we know today. 90% of it was covered in water. However, it wasn't blue. It was covered by large clouds of methane, turning the atmosphere yellow. On land, conditions were much worse. Volcanoes erupted for millions of years, and the sound of their explosions was one of the few noises in an almost silent world. The planet was a place of toxic air and rivers of molten rock. Life as we know it was impossible then. But in the sea, something was stirring beneath the surface. There was a large patch of microscopic cells doing something new at the time: photosynthesis, using the sun's energy to grow. This was very important because these microscopic cells, known as plankton, would become the reason for the emergence of all plant life on Earth. But that's not all. One of the byproducts of photosynthesis was a gas, the missing component without which no animal life could exist on the planet. This gas is oxygen. Over 2 billion years, marine plankton produced so much oxygen that it changed the color of the planet. The yellow gradually faded and was replaced by blue. The planet became a new world, suitable for life. Today, millions of years later, we can glimpse what this past life looked like. Life under the sea resembled life in ancient times. All you see here are animals, most of whose bodies are delicate, living on the sea floor. They all have senses and are fed by filtering and selecting plankton. Not all animals are stationary. Some move and explore the ocean floor. It might seem that the waters were a safe haven for life, free of any threats. But this is not accurate. This creature, known as the rainbow sea slug, has a sinister and predatory side. Its favorite prey is anemones. 530 million years ago, predators underwent a major transformation in the ancient seas. Hunters had to adapt or face extinction. One group adapted in an unprecedented way. Though they were individual organisms, they managed to split into layers and move freely. These creatures are called jellyfish. 530 million years ago, jellyfish were the first animals to escape the seafloor and swim freely. But they did not escape predators. Armed with toxic appendages, a type of anemone quickly preys on small jellyfish. Due to their abundance, it seemed impossible for jellyfish to escape, but those who could swim quickly managed to flee. Thanks to their swimming ability, jellyfish were the first creatures to leave the shallow waters and enter the vast, open blue ocean. For the animals still fixed to the ocean floor, we will see a very strange creature. The trilobite, one of the earliest new breeds, adapted and escaped predation in a peculiar way. It had a shield-like exoskeleton for protection. But protection from what? It was Anomalocaris, a bizarre-looking creature whose name means abnormal shrimp. In the shallow waters, 508 million years ago, it was the most powerful predator in the world. Although the trilobite had a shield, it could only logically hide from it. But away from the valleys, there were no places to hide. What made this hunter special was its speed. Unlike jellyfish, it could swim in any direction quickly. When the trilobite felt trapped, it curled up like a ball. This abnormal shrimp could not eat it, and when it left, the trilobite would move again and search for one of the greatest features of the ancient ocean, the breeding grounds of its kin in the story of life. Trilobites were so successful that 80% of all animals, including insects, spiders, and crabs, descended from these ancient arthropods. But their shield couldn't protect them from everything. After 400 million years, a new period of life began with greater diversity than ever before. Trilobites were still present, and their shields became stronger. In this place, at the coral reefs, a new type of predator appeared, the ancestors of octopuses and squids, belonging to a dominant lineage known today as cephalopods. The largest of them was 8 meters long. Of course, trilobites were much smaller in size. Their large size wasn't the threat. The threat was how they captured their prey, even if they didn't see it. Hunting skills didn't just rely on vision. They could also use sensation. All the trilobite could do was get as far away from them as possible. They had a beak-like mouth that could pierce the toughest shields, becoming the new rulers of the deep seas. But a very important creature would appear and take the spotlight immediately. The armored arandaspes, an ancient type of fish that didn't yet have a jaw, so it could only swallow leftovers. Among them would be one that would change the course of history. It had an internal skeleton that made it fast and agile. This skeleton is known as the backbone, and scientists say that fish like the armored arandaspes are the ancestors of all other vertebrates, amphibians, reptiles, mammals, and birds. But for now, vertebrates were still in their infancy, with a long journey ahead. After 20 million years, life faced one of its greatest threats. The climate suddenly cooled, with significant consequences. One of these consequences was that the sea began to freeze. For the marine animals present at that time, this was a disaster. The seas became frozen graves. The first mass extinction in the world resulted from this deadly freeze, caused by a 60% drop in carbon dioxide levels. Subsequently, the planet was engulfed in an ice age lasting 200,000 years. Nearly half of the planet was covered in ice, leading to the extinction of 85% of all life forms. 85% of the creatures were lost forever. The surviving animals were small and managed to migrate to deeper waters. Animals like the nautilus, small descendants of the giant Nautilus archives, still exist today after hundreds of millions of years. The stable nature of the deep ocean helped these animals survive the ice age. All animals, including the spider crab, moved there as well. These animals live cautiously on the ocean floor, alongside vertebrates that don't prefer deep water life. Food was scarce in the depths, where only 10% of today's fish live. This place isn't one for easy dominance, unlike cephalopods, which became the top predators in the depths. In certain deep-water locations, the water glows with bioluminescent plankton. A lurking squid observes the world with its large eyes, providing clear vision in the darkness. It watches and waits for the right moment to catch shrimp and everything else it needs. The squid's exceptional senses helped it adapt perfectly to a cold, dark world. After 200,000 years of the Great Freeze, a blue vein appeared in the ice. Carbon dioxide levels rose, causing temperatures to increase, and the Great Thaw began. Initially slow, the thaw quickened, with glaciers hundreds of meters high flowing into the warm seas. In a few thousand years, nearly half of the planet's ice melted, and in a few more thousand years, it disappeared entirely. For the animals that had retreated to the depths, these conditions provided an opportunity to return. Today, near the coasts of Australia, we see a giant squid resembling its Ice Age ancestors. It enters shallow waters in search of a mate. However, many have come before it, including the dominant male, who protects his partner from other males. A small male watches and challenges the leader. The small male, taking advantage of the leader's distractions, sneaks quietly and changes color to perfectly mimic the female. Using intelligence instead of strength, sneaks right in. Now, the leader believes he's protecting not just one female, but both. Exceptional intelligence and powerful senses have allowed cephalopods to survive in all of the planet's oceans for 70 million years since the Great Explosion, a period known as the Devonian era. Vertebrates began their journey here with Dunkleosteus, belonging to the lineage of the small armored arandaspes. Do you remember it? This fish grows up to 9 meters long and isn't as weak as its ancestors. Even its young are large and formidable predators. Suddenly they encounter something. Ammonites, descendants of the nautilus that still live in the depths today. Vertebrates are always characterized by speed and ease of catching prey, but ammonites have their trick, jet propulsion, which helps them evade the fish. When the fish chase them, the ammonites use the same defense as their ancestors, protecting their bodies with shells. In the past, this defense was successful, but Dunkleosteus developed a weapon unknown to its ancestors, a jaw capable of biting and crushing prey entirely. All it needs is for the prey to come from the right angle. The young can't break the shell, but the adults can crush it. With a backbone for speed in the water and a strong jaw for predation, vertebrates have remained at the top of the food chain ever since, with no one able to dethrone them. Today, there are over 30,000 species of fish, 40 times more than the number of cephalopods. Despite their remarkable diversity, they all share a backbone for speed and power, regardless of size, and a jaw capable of biting and predation. Not all jaws bite. Some fish use them to protect eggs, others to build places to attract females, and some use them not just for eating crabs, but also for one of the most terrifying displays in nature, where they scare off enemies. For these fish, size matters, and their large jaws help them dominate their living areas on the seabed. The large jaw also helped a notorious group of fish dominate the upper waters. More than 400 million years ago, many feared them. Sharks, with a combination of a backbone and a strong jaw, have very sharp senses, detecting prey from hundreds of meters away. They also have size and powerful predatory strength in any ocean. In Western Australia, all these fish gather for protection, finding safety in numbers. Sharks have a special attack plan. Some rise from below to trap fish at the surface, while others stay underwater to prevent fish from escaping to the depths and shallow waters. Now, hundreds of sharks are present, but none attack immediately. Once they sense the fish are tired, they begin predation in a flash. Sharks have remained almost unchanged since the Great Explosion, succeeding due to the fall of their greatest competitor. 360 million years ago, in ancient seas, Dunkleosteus dominated for 20 million years, so fierce that sharks couldn't compete. But something catastrophic occurred, linked to plankton from billions of years ago. Plankton, the catalyst for animal life, could end it in an instant. A sudden increase in ocean nutrients caused an unprecedented rise in plankton numbers, leading to their decay. This resulted in a drop in ocean oxygen levels, suffocating animals. Those unable to escape the toxic waters faced extinction. Dunkleosteus was among the many lost creatures. Most of the world's coastlines became filled with dead animals. The few lucky ones, including sharks, survived. 80% of marine life couldn't make it. This was the world's second mass extinction. However, this was only half the story. The nutrients that caused the plankton to bloom and decay didn't start in the sea, but on land. Plants released them during one of the most spectacular events ever, the greening of Earth. The planet, once a barren volcanic land, became filled with life. This new world allowed plants to spread, followed by animals starting a race to dominate the land.